We would like to show by mathematical induction that 3 plus 7 plus 11 all the way until the last term 4n minus 1 is equal to n times 2n plus 1. So the first thing that you want to do, you want to show three statements. Just show them, write them out. P1 statement, pk statement, pk plus 1 statement. So P1 takes only the first term because the n value is 1. There are n terms on this left side. When n is equal to 1, we're talking about the first term. So 3, and on the right side, we're going to substitute n with 1 because we're talking about the first term, so n value is 1. So 1 times 2 times 1 plus 1. And we're just showing it. We're not showing it true yet. pk statement here, pk statement, is substituting n with k. So 3 plus 7 plus 11 plus 4k minus 1 is equal to k times 2k plus 1. pk plus 1 statement, on the other hand, will substitute this k with k plus 1. So 3 plus 7 plus 11 plus 4, and instead of k, we're going to write k plus 1. That's the new k. Think of it as a new k plus 1 minus 1. And that's equal to k plus 1 instead of the k here. And again, 2 times k plus 1 here instead of k. And then plus 1 after that. Okay. So now that we've showed that, we have to show P1 is true. P1 is true since 3 is equal to 1 times 2 times 1 is 2 plus 1. This is equal to 1 times 2 plus 1 is 3, which is 3. Good. So P1 is true. The left side is equal to the right side. Now assuming pk statement is true for arbitrary k value, we will have as a result pk plus 1 statement written like this: 3 plus 7 plus 11 plus all the way plus 4k minus 1 all the way until the last one here, but we assume that this statement is true, so we can safely add one more term. And adding one more term means that we're adding basically this term to make it pk plus 1 statement, right? Because so far it's pk statement. We need one more term. So we're going to add this term to make it pk plus 1. So 4 times, do not want to make this like a summation sign. So 4 times k plus 1 minus 1, okay, is equal to this, right? So that's going to be what? So let's make this, let's simplify this as much as possible to k plus 1, and this is going to be 2k plus 3. Okay, 2k plus 3. Okay, or we can basically make it look like 2k squared plus 3k plus 2k, so that's plus 5k plus 3, right? So revised right side is right here, 2k squared plus 5k plus 3. So now what we need to do, we're going to say this means that we're going to compare this statement with this statement. Notice that the left side is almost identical except this term being added that is missing here on this left side. So if we added this term on both sides of this statement, it should give us pk plus 1 statement. And then we're going to have to verify the right side, and if we show it to be true, this statement, Because right now we assume it's true. We need to show it's true. If we show it's true, then Pn, the given statement on the top, will be true for all n. So this means that 3 plus 7, I'm just copying this guy, plus all the way until 4k minus 1. And again, I'm going to add this one to this left side, right? Because we copied the left side. Now we're going to add this term. So we're going to indicate it in red. Plus 4k plus 1 minus 1 is equal to this right side. And then add that red part again, because we have to add it on both sides, right? In order to not violate the concept of equation. K plus 1 minus 1, okay? So now what we need to do, we made the left side already identical, right? This is a pk plus 1 statement, left side, notice that. And we have to make the right side show that this right side is equal to this right side. If we show that this whole thing is equal to 2k squared plus 5k plus 3, then we have shown that indeed these two sides are equal. And pk plus 1 statement is true. So let's transform that. The right side becomes, let's see. So I'm just going to copy that right side down. Plus 4 times k plus 1 minus 1. Let's see what that equals to. This is equal to 2k squared plus k. And then this is equal to 4k plus 4 minus 1. 4k plus 4 minus 1. And this is indeed equal to 2k squared plus 5k. The like terms are here. These are like terms. Plus 5k, 4 minus 1 is 3, right? So bingo, look what happened. We indeed showed that the right sides match, right? These two sides, they match. So and what this basically means, we can say so that statement, this statement here, 3 plus 7 plus 11 plus all the way until 4k minus 1 plus 4k plus 1 minus 1. I'm just copying this left side of the statement, is equal to 2k squared plus 5k plus 3, right? So we can say so that the statement holds true, since the statement is precisely pk plus 1, right? Because we showed indeed that this left side is equal to the right side, like we assumed in the beginning, but we showed it to be true through algebraic manipulations. So since the statement is precisely pk plus 1, by the principle of mathematical induction, Pn holds true for all n. Thank you so much for watching. Hope this was helpful. See you in the next video.